Greetings, my name is Ryan Nix. I'm a solutions architect with Amazon Web Services. Joining me here today is Eduardo.
Hello, Ryan. Hello, everyone. My name is Eduardo. I'm a partner solutions architect with AWS.
Eduardo, I have customers who are using IBM Planning Analytics. They're using that for financial tracking, financial forecasting, large scale business decision making processes. Those same customers are also utilizing technologies like Salesforce, for example, for CRM solutions, sales pipelines. And if you're doing financial forecasting, these two things kind of need to interact with each other. And what we have is a lot of customers that are asking the question, how do I get the relevant data from my Salesforce environment into something like a planning analytics SaaS implementation on AWS? This is fun because there's a lot of disparities of how the data needs to be formatted and things. So run us through, firstly, how do we connect to Salesforce? What are some of the options for how we can pull that data out? How do we transform that data? And let's unravel this as we go.
Yes, right. So yes, this is a very common ask that we get from customers running planning analytics. They want to integrate to Salesforce. They want to integrate to other data repositories, right? So in this example for Salesforce, what you see here, Ryan, is that we can use a managed AWS service called AppFlow, and it lets you connect to SaaS solutions like Salesforce to pull data from Salesforce databases, right? Now, once you have established that connection, you can push data either already in Parquet format or in CSV format. It really depends on how you want to build your pipeline. In this example here, I'm pulling data from Salesforce and I'm pushing it into S3 buckets in CSV raw format because I might be interested in doing other things with that data.
If you put it in a CSV format into S3, something is going to have to then take that, interpret it, and go through a bit of a transform or like an ETL function.
Correct.
I'm assuming that's where AWS Glue is coming into this picture over here.
You're absolutely right. And so what you see here in this picture is we're using Glue, and we're using Glue in different steps. And because I want to build a pipeline that always runs through the exact same process, because I'm interested in capturing, maybe I want to do like a day-to-day update on the data that's coming from Salesforce.
This could be weekly, monthly, daily.
Correct, cycles. Exactly. Yeah. So I'm running through several processes here, and I want to orchestrate this, right? So I decided to use AWS step functions here to orchestrate this entire process. So what I'm doing with Glue is I'm connecting to my S3 buckets, and then I'm running crawlers to discover the data that I have there, right? And I can decide on top of the raw data which columns are interesting for me on that data that's coming from Salesforce, because I don't want to push everything into planning analytics, right? Okay. So I can be running some Glue ETL jobs here to clean my data and prepare the data to be uploaded to PA. So I'm running several Glue steps here, right? And at the end of those steps, I also want to have a metadata catalog, right? Because I need to be able to query that data as it sits on my S3 buckets, now in Parquet format.
Okay, I'm seeing Athena over here, and I'm assuming Athena has a role to play in the creation of that catalog. And I'm assuming it's going to be taking the output from Glue, which is now in a Parquet format, in order to do that as an ingestion process.
You're correct. So what's happening here is that I can be actually bringing in large volumes of data, right? And AWS Lambda that we see here in this picture has a 15 minutes time up, right? So I may want to break that data apart, so I actually upload chunks of data, right, and avoid some kind of connectivity.
So this is a parallel processing mechanism. You're
exactly
repeatedly invoking it.
So I'm invoking Athena in a parallel way, and I'm telling Athena, hey, fetch my X lines from my metadata catalog, from my Parquet file. Now I want to, from line 1,000 to 2,000, from 2001 to 3,000. I'm breaking it apart, right? And then I grab these small chunks of data, and once the query on Athena is finished, I push that information into SNS, because I may want to inform some data analytics scientist, data science, or whatever team is running this. Hey, the processing has finished, your information is available. So what happens from there, I could be sending email notifications, and then I also send that to an SQS queue. The reason for that is because I want to do an event-driven architecture here, because that's completely serverless.
So the nice thing about the serverless approach is firstly, it's serverless. You're not worrying about operating systems. There's no patch management. There's no operational overhead to this. It extends beyond that. I love serverless because now you don't worry about all of the nitty-gritty little things like network configurations,
Absolutely.
routing, security groups. It's a much leaner approach. The Lambda function that you've got there, I'm assuming, is then loading that data into via an API directly into planning analytics.
You're absolutely right. So planning analytics SaaS exposes APIs, and I'm connecting to those APIs. And what my Lambda function is doing is it's using the TM1Py libraries. So this is a Python code that I have in Lambda, and it's using TM1Py, NumPy, Pandas, and it's building the data frames based on the data packets that I'm getting from SQS. And it's then making a call to the planning analytics APIs to check if I already have cubes and dimensions for that data available in planning analytics. If they're not there, I'll simply create those cubes and dimensions, and then I push the data into planning analytics.
Okay, so this is fantastic because this means that the users of planning analytics don't actually have to go and create the dimensions, the cubes, the views. Right. They can simply consume.
Yes.
There's nothing stopping them from extending that. They can extend those dimensions. They can actually go and create it. They can build on top of that.
They can build on top of that. Inside planning analytics, they can use all the PA capabilities to extend on top of the data that they're bringing in, right?
Now, what about customers that have a lot of information in planning analytics that potentially they want to bring back into a different system? So they want to bring it back into AWS. I'm assuming we've got a reverse sort of process here as well.
You're absolutely right. So we can use the same approach of AWS Lambda with TM1Py, and we can connect to the planning analytics API endpoints, and you can run MDX queries inside Lambda so that you can query your cubes and dimensions, get the data back that you need, and then once you have the data with your AWS Lambda function, you can basically send it anywhere you want, right? So imagine you want to send that data into Amazon RDS for IBM DB2, right? Or if you want to send that into a data lake or whatever it is that you need to do with it, you can do it that way, right?
Okay, this is fantastic. Is this something that is being packaged up as a solution, or is there a way that customers can go take a deeper dive on the building blocks of this, potentially like a blog?
Right, absolutely. So we do have a blog published on the IBM and Red Hat blog channel on AWS that goes into a lot of details of how customers can actually build this. We have all the Lambda function code available there so that they can use that to experiment and see how these things are working.
I'm assuming that's going to be a link in the description below. Somewhere.
Absolutely, yes.
Right. Thank you very much for this, Eduardo. As always, a fantastic pleasure having you here.
Thank you, Ryan, and thank you all.
Thank you.